I'm Björn from the Bavarian R2 Builders, and welcome to the next installment of our video tutorial series on building D-Ov2Evo, which is our improved and expanded version of Michael Baddeley's very cool 3D printed Star Wars droid D-O. Last time we talked about putting the electronics into the body and making the body basically finished. This time we're going to look at the head and the neck and do that assembly, and that will hopefully conclude the mechanics assembly series. So the first thing that we got to do is configure our three head servos. They have the ID 2, 3, and 4. These are not configured yet, so we're going to do that live as we go along. Servo ID 1 is of course in the body, and it's being powered by the 12 volt BEC hooked up to the battery at the moment. Now, that is a 12 volt servo. The three servos that we have in the head are actually 5 volts. Now, you can run them on 12 volts and they will respond for communication, but they won't turn the motor, they go into over voltage. So we got to run them off of 5 volt instead for configuration and for test. And later in the head, we're going to run them off a 5 volt BEC. So we'll disconnect the power connection to the board here. And then the Dynamixel control board has a small jumper that has two positions. One is V in and one is plus 5 volts. So V in means it's taking power from that green clamp, plus 5 volts is it's taking the power from the Arduino, meaning in this case from USB. So we'll just jumper that over. And now we'll be able to power all the servos via USB power. And of course, that doesn't really work for the servo that's in the body, and we don't want that on the bus anyway while we're configuring. So we're pulling the Dynamixel cable that's coming from the main neck axis off, and we just connect the individual servos one by one. All right, just a simple cable and plug that into number 2. And now we're ready for configuration. So as I said, power is just going to be coming from USB. Now you see that the servo itself has this little window there with an LED behind it. And what that LED should do is it should turn on for a second at power up and then turn off. The LED staying on or blinking is going to signal an error state, so that's what we're looking for. Now I'm plugging USB in, and you see it's not going in directly. I have this handy little extension that will allow me to plug USB in even while the tire is on. And we'll see what that LED does. Let me turn this out of the way just a bit. As I plug it in, you should see that LED wink on for a second and then turn off again. There you go. So it's getting power and it's not reporting an error. So the next thing that we'll have to do is flash the Dynamixel test sketch onto our Arduino via the USB connection that we just plugged in. And for that, let's open VS Code and load the Dynamixel test sketch. Okay, in VS Code, you want to click the little button with the right arrow at the bottom. That will build and upload the software. And then you want to click the button that looks like a 2-prong connector. Again, at the bottom, that will open the serial monitor. Now we got to init the bus first. Dynamixel standard baud rate is 57,600. It's scanning, it's finding that sensor. First thing that we're going to do is change the ID. It's currently got the ID number 1. We're changing that to 2. And then we're also changing the baud rate for the newly changed ID 2 to 1 million. And just to check, we're doing an init with 1 million, and if it finds the servo, then we're good. Rinse and repeat that with the other 3 servos. Now they all have their respective IDs and they're all at 1 million baud. So we can now connect them in series. And you can hot plug this. The servos don't care. It's just the bus in it that's going to make the Arduino then learn about them. And as you hot plug these, you should see the individual LEDs of the newly connected servos coming on for a second and then winking off again. And then we're going to go into our dynamixel test, init the bus with 1 million baud. It's scanning, and as you see, it's finding 3 dynamixel servos with the IDs 2, 3, and 4. That's what we want to see with 0 error status. And then just for kicks, let's move servo 2 around to 0, back to 180. And then let's try that with all 4. All right, these all work. Now, if you look closely, I've moved them all to 180, and 180 is their basic rest position. If you look very closely, you will see that both the servo housing and the servo wheel itself have this little notch. That's the center position. And for us, we always call that center position 180 degrees because we can then move to 0 in one direction to 360 in the other direction. If you want, you can mark this 0 position so that it's visible more easily with a white lacquer marker, for example, white paint. Oh yeah, and of course, before we put it into the NIC, let's not forget to put the jumper back to V in, which is going to run it at 12 volts for the servo in the body, and also reconnect that DC-DC converter to the battery output on the main board. All right, so we're going to build the neck from the ground up, and that is basically starting at this connector here. While we're at that, let's talk about connectors real quick. What we have in here is a 10-pin so-called box connector. You can find them on Amazon or on Ali. They're really simple. They're just 10 pins and this box around them. These are connected in the back to the dynamixel connector, the I2C connector, and also what I've put in here is basically just 2 wires to connect a speaker, to have that option to connect a speaker in the head cone at some point. It's not very important. We have a convention that's in the wiki that's documented that says which pin is which. It's not very important that you follow that convention unless you at some point want to exchange one DO head or DO neck with another one. We just think it would be a good idea to document this to make sure that people don't forget anything. On the other side, we're just using standard, these are called DuPont connectors. So you get them in 1 pin up to 20 pins. So basically you can look at these things as well. We use 2 5-pin connectors that are using these crimp pins, crimped with a pair of crimpers. Cracking investment, absolutely recommended. And then we take 2 of these and basically just super glue them back to back. So this is not a 10-pin connector. This is 2 5-pin connectors super glued back to back. I've also marked the pin number 1 here. In our convention, pin number 1 carries the ground pins for both I2C and the dynamixel, and then the rest basically moves on from there. And at some point, this is just going to plug in here and give us that connection. The actual plastic part on the neck that's going in here is this one. It's in the main neck directory. And in the battery version, it just has a hole, an opening in the middle. In our version, this is routed out so that you can basically just press fit this thing in. And the idea is that you, at one point, you just press it through. It's actually a pretty tight fit. And then you push it in and make sure that it can't go any further. It should be flush at the back here, but it doesn't hurt to just push a bit more just to make sure that it has a good connection. And as you see, it's so flush that and it's so tight that you can't really move it. Just for safety, once you're sure that everything works, you can just fix this with a drop of super glue. And that is then basically the bit that goes in with 3 long screws and is then tightened to the base, which means that basically you can pull it out, plug it in without having to do anything in terms of individual connectors and so on. One thing to keep in mind is never hot plug this. I'm not quite sure what's causing it because the servos should actually be hot pluggable, and I've hot plugged them many times. Could be the assy, but something, maybe it's also just the spike current from the battery, from the DC converter that we're going to put into the head. But this fries Arduinos, so never hot plug this. Make sure that the droid is always switched off before you plug the head in or remove it. All right, before we move on, we have to do some prep work that I've actually already done here. So this is going to hold the main neck. The cables are going to be routed through here, through that hole into the main neck bar. And this guy gets a square nut in here. This is an M3 square nut. I think I've actually super glued that in. It was a while ago. You can also just use Michael's usual method of putting in a dab of hot glue here. And there's another trapped square nut that we're going to need, and it's actually in the main bar. It's in there, if you can see it. See that little silvery gleam. And that is going to get screwed and secured from the back here. So this is how that stuff fits together, right? So there's a screw going through here, and then as we affix it to the main body, there's another one of these 3 screws that affix the neck to the body. Goes also through that, so it's secured with 2 screws. It's a really nice design. I like it. Okay, now the cables that we have here, it's important to keep them nice and long in the beginning. As you see, we have this I2C cable. I just took a very long one, has the connector at the top. There's a 3-wire servo cable that is going to be connected to the dynamixels up there. Doesn't have a connector yet. And there's the last one is a loudspeaker cable. Going to exchange these connectors later. So these are going to get routed through the main neck, and then after we've routed them through, first through this, then through this, we are going to, no, actually before we route them through this, we need to route them through this guy. This is the bar skin that just gets pushed over here to keep everything nice and clean, hide the cables. This is the printed one, which is totally fine. I personally like it a bit more rigid, especially in such a long lever. So I've taken a bit of carbon tube that I've routed out with a Dremel up here that has exactly the same measurements. So that goes over here nicely like a glove. All right, so let's see that we can put it together without making a knot into our brains. So the first thing that we're going to do is get these cables through this dude from the back, up here, out the hole, then a mixel cable, I2C cable, and then the speaker cable. It's easier to pull them out through this hole first and then thread them through here. All right, nice. Good, so we've got this stuff. Now, for the sake of the demonstration, I'm not going to glue this, but at some point, for the droids that I built last, I've actually just took these two, threaded a couple of M3 screws through here with a nut in the back, and then put some super glue in the middle, and just glued everything together nice and tight. Definitely helps to keep everything one unit. As I said, for the sake of this video, I'm not going to do it. All right, next up, we go through the bar skin. With the routed out part at the top, of course. Where'd my I2C cable go? In there somewhere. There you go. All right. Good. So we pull these flush, and we thread these guys through the main bar. Kink them around, and they come out up here on the side a bit, because we're going to put the main head nod servo on here. So we'll just have to wiggle this a bit as we move the main bar into its bottom housing. Let's watch closely that the holes for the screws are actually doing what they're supposed to be doing. And this is now a bit difficult, as you have to thread the cables around that kink in the top here, making sure that you're not flexing anything off. But this should be seated nice and tight. I don't think we can go any more. We should see that screw hole there. Not quite sure that, oh yeah, there it is. It's not quite where I need it. Okay, there you go. Now we got it. We fix it with a 3x8 screw. There you go. Bam. Okay. Good. So we're not quite so tight yet. There's one important thing to look out for. That's maybe not super elegant. These cables here need to move to the side just a bit in order to let that screw. See that one that's going to affix the neck to one of the three that will be used to affix the neck to the body. This is a bit of an exercise in wiggling and getting the cables out of the way. I'm sure you can do it, and usually the screw then just stays in. I think I've used actually the wrong length here. You know what? I think it's a good idea to do a quick test fit. All right, it is as I thought. I used a screw that's not long enough for this one, so I'll have to wiggle it out of the cables again. These are 35mm long M3 screws. They go into the body quite a bit. We'll do a test fit anyway. We can't screw the top one in, but let's see that this works. So we get 3 screws in here, thread them through this disc. Again, gluing it would help. Then put them in here. make sure everything is registered nicely. Push to make the connection. And of course we can't tighten the top one at the moment, it's not going to grip. Yeah, it doesn't. Okay, but that's the body and the neck right there. Everything works. Everything's nice and tight. And then just for later reference, once we're done with everything, we will add this that is going to connect to the back lever that doesn't carry anything, that's just for show here in this version, so it doesn't matter if it's wiggly. And then we'll add this cover disc that has an M3 screw of, I think that looks like 6mm glued to the back of it, and that basically just screws over here. Come on, don't let me down. There you go. There's a bit of glue still in that square nut I put in here. Okay, and that's basically the bottom of the neck done. Next up, we're looking at the head box. Very first thing that we do is we take the head box bar, I think it's called, and glue that into these two pockets there, right, so that it sits in there nice and tight. It provides some stability to what's otherwise a pretty flimsy part. I'll do that in a second. And what we also need is we need to make a custom connector. So first of all, these cables at some point are going to go into this hole here into the head box. And you see that has in our version a little hole, a little nook at the bottom that you can use to push the bar in here and to route the cables in there. You see, because they have this little catch here. Once that's in, you can, if you want, secure these with a cable tie, and then the whole thing is going to turn like this. So it's not quite optimal. Possibly I'll redo this one quickly with a bit of a flange here to give us a bit more wiggle room. Anyway, it does work. Now, this is basically then these are the cables that come out here. And the first thing that we're going to connect in here is going to be our first servo. That's going to be responsible for pitching the head front and back. And that servo is one of these guys. Now, if we remember, yeah, it's actually number 2. If we remember, the servo in the bottom of in the body of the droid is actually running with 12 volts. What's coming out of it and goes through this dynamic steel servo connection is also running 12 volt. Now these guys don't run on 12 volt, they run on 5 volt. So what we're going to do is we're going to make a cable that basically inserts a 5 volt UBEC into the connection. And the data cable is going to be routed straight through, but the ground and the voltage connection are going to go into the servo and are going to take the 12 volt on one side. Make sure you look at the direction of the arrow that's printed on here. We are going to get clean 5 volts out the other side. Okay, and for that we need to shorten first this cable here. It's far too long intentionally. We're just going to cut it off. So at a length where if we have a plug on here, we can still pull the whole thing through this hole and get the bar out before we actually have to pull the plug through that hole. That's going to allow us to assemble and disassemble the whole thing at will. So if we're looking at this roughly, I don't know, with this thing out, roughly 2-3 centimeters in, we're going to cut this thing off. And then the connector that I'm going to be using is one of these guys. These are called JST SM connectors. They come in a male and female variety, and they have the great advantage that you can't change the polarity. You can't get them in like this. It only works like that. And also they click nice and tight, so there's no accidentally pulling them out. But at the same time, if you don't have these guys, you can just as well use regular DuPont connectors in a male and female variety, in which case you just have to mark which pin is ground. You can't really break anything by messing up the polarity here. Because the center pin is going to be your 12 volt, and the outside are going to be ground and signal. So if you accidentally switch them around, your center pin is still going to be 12 volt. It's not going to work, but it's not going to blow anything. So let me do that real quick. All right, here's my crimped cable. Fits through, but still is nice and short. There you go. And then for the other side of that cable, as we said, it needs to go through this this DC-DC converter in the direction of the arrow. But what I'm going to do is I'm actually going to carefully cut open the heat shrink here and victimize one of these dynamixel cables, and actually manufacture a dynamixel cable that has that goes directly into this U-back on one side, basically coming out of that U-back with the 5 volts, and then this bit plus the remaining strands. I'm not going to cut this off completely, cut this away completely. I'm going to leave one strand longer, so basically the plus and the minus for these guys are going to be connected directly on here, and then these will be cut off, and then I'll have 3 cables coming out here, the 2 ones from the U-back plus the data cable on the dynamixel. All right, so here's the adapter cable I made. As you see, it's got the red and black wires still coming out. This is from the original input for the BEC, or DC-DC converter. And on the other hand, on the other side, I've just soldered the VCC pin to the center pin of that connector. And I've actually checked the way that this connector is supposed to be connected. We also have that in our reference in the wiki. If you hold it like this, so that these 2 little wings on the side left and right are on the bottom, Then the leftmost one is ground, so that goes into here. The middle one is plus whatever, VCC. In this case, this is going into a 5-volt servo, so this is 5 volt coming out of the DC-DC converter, going from 12 to 5, and then the data cable is basically just routed through. So let's give this a quick test. Always a good idea to test this stuff individually. I've already tested the output here. So this carries 12 volt as it should. It goes in here, as you see. The color coding means that the black wire that I have here is ground. The red wire is 12 volt input, and the white wire goes into the signal pin. So most basic test, just switch it on, make sure it doesn't let out any magic smoke. Fine, that works. Then we'll connect one of our servos. And this is servo number 2. And we'll switch it on and see if that LED is giving us a quick red light. Fine. I still have the Dynamixel test software running on this box here. So I'll connect the droid to the serial connection real quick. Give it power, and then see what my Dynamixel test says. All right, in it with 1 million baud, and it finds the Dynamixel in the body with number 1 and the one that we just connected with number 2. All right, and we can now just do a quick move. I'll move number 2 to 0 position. Everything powered off. I'll add the now shrink wrapped BEC with the Dynamixel plug. And we have a chain of number 2, 3, 4 going on here. Still have the Dynamixel test software running on D-Ov. Plug this in here. Give it battery power. Watch as the servos all blink. Go into the terminal. Go in it 1 million. And just glue in a screenshot. But it is finding all of the Dynamixels 1, 2, 3, 4. So let me move 170. There you go. 190. And then let's see that we move the rest of the servos. Move 2 to 0. Move 2 to 180. Move 3 to 0. Move 3 to 180. Move 4 to 0. Move 4 to 180. Wonderful. Okay, so the servo connection works. Okay, next, to actually mount this servo, just to run you through real quick how this is basically working. There's this servo couple. Oops, there's the servo couple here. This gets screwed onto the servo actuator plate, and it fits on the neck axis like so. It has a hole for a trapped nut up here, so that takes a M3 square nut as always. So that goes on here, And then we have a assembly that looks like this. So this guy is going to be inserted in, see these little slide nooks here on both sides. So that basically goes in like this. With the servo in, so it's going to be much easier later. And that whole thing is going to get screwed to this bar. So this assembly is basically holding everything in place. There's no glue, or there doesn't need to be any glue. Since the whole thing here is screwed tightly together, it can play just a tiny little bit in this axis, but that's going to be stopped by the top plate that's screwing into this recessed area here. You'll see that come together in a minute. Okay, let's assemble this. All right, so what we're going to do is we are going to, so I've already glued in a square M3 nut in here. So we're going to add this dude, that's number 2, to this bracket real quick. All right, next, this guy goes on. Now, orientation. This is the top side, and I want to have this hole for the screw to be accessible from the bottom. So I'll add it like this. And as you can see, this was a bit tricky. That hole for the square nut there has a screw hole in there. So normally the square nuts are all held in place in Michael's design with some hot glue, which you can do, but then you can't access that hole anymore. So what I'm going to do is not fix it in with hot glue, just use these 3 screws and then put this guy in here and just hold it in place with gravity until I get the screw in. All right, as I said, this is the top side. I want the screw hole to come out on the bottom. This is again held in place with a bit shorter, I think 2.3 self-tapping screws. Right, make sure these are nice and tight. All right, there you go. So now we add a square nut. And we go into here and fix the whole thing by sliding this over and into the recesses on both sides. And then I'm going to turn the thing around and put an M3 screw into there. Okay, fine. So that's the whole secret. There's nothing more to that assembly. So this still has a bit of wiggle room in this direction. And there's 2 things that are going to hold this in place. One is going to be the plate that we're screwing on top here, and that's going to be fixed to that one single screw hole. That's going to hold it in place. And the other one, the other thing that's holding it in place is this guy here. That gets pushed over the top here. And once that's in place, essentially there's no wiggle room here anymore. Good. Next bit of the assembly consists of this guy here. That is the one that will at some point go on here, right, and sit in that recess. So this takes a servo, obviously at the bottom. And it's done in such a way that you can still access that screw hole, so we'll do this assembly first in total. It's actually servo 4, that's not correct. Should be servo 3. So that servo number 3 goes in there. Then this lid comes on top, and then this guy here is put on top of that and affixed to the servo with those 4 holes. And then this takes the 4th servo with the actuator down and looking to the front. So let's do that real quick. Right, good. Next up, we put this guy on top. See, it has an opening in front. This is where it goes over the hole down there at the bottom so that you can reach through. And this is just screwed in with M3 screws. There you go. Wonderful. I think I'll leave it at those 2. Not like you need a lot of weight there. Okay, so this is the back. This is where the rubber cables are going to be inserted at some point. So what you want to do is you want to take the last servo, that is the head roll servo, and put it in here, actuator to the front. And this is actually where we need the other side of the servo as well. You can buy these separately, they're in the BOM. And I'll put one of these guys in real quick. So this is the kit they come in. It's an FPX 330 H101. I should have one opened somewhere lying around here, but can't be bothered to look for it real quick. So this comes with mounting brackets for all purposes, and it also comes with mounting hardware. And there you find these discs, and they're basically just compliant discs to put on the other side of the servo, right? So you have the active actuator on one side, and the other side is just compliant so that you can mount it in some bracket, or so that you can mount a bracket like the one that we're using to mount our head onto it. So the way this works is this thing, plus there's a plastic nut insert that goes in there, and then you basically just fix these 2 with a screw here, and then this one can turn nice and freely. Okay, so let's mount this actuator here nice and freely in the back. Fine. We'll get this added and put our usual long screws from the Dynamixel pack into here. Good. Now, let's put this on top of the head box. Well, before we put it on the head box, let's just very quickly say something about cable routing. So what I've done here is I've just wrapped a very small cable tie around the cables coming out of here, just to make sure that everything is nice and in place and nothing snags on the inside here of the head box. We want this to be able to spin freely. And then the rest of the cables get routed up top. and the dynamixel cable comes from the neck into dynamixel number 2, and then we have a cable coming out of this that is then going into dynamixel number 3. So first we add this little slider to the whole thing that is going to close up the head box, and we route the cables through this hole at the top. All 3 of them. Speaker cable is obscenely long. We're never going to need anything close to that length. I don't want to trim it now. Still time for that later. Okay, we routed that through. So what we're going to do now is basically just slide this guy here onto our head box. If you want to move the cables out of the way, there's a little nook and cranny here. If you really want to be anal about it, you can also use a cable tie to fix that here. But as soon as we slide this guy over everything, it's going to be held in place anyway. At the bottom, this should lock in. It's a bit tenuous, but it's not really important. So, got our cables routed. We can maybe push them a bit back to have everything sit more flush. And then this guy here, let's remember this is the left side. So this is the front, which means that this dude here goes on top like that. And we want to route the dynamixel cable into here. Well, actually, I just plug it in here. So then we got that assembled, and we'll go with this dynamixel cable out the other side. And through this side into that dynamixel up there. Okay, remainder of the cables. Speaker cable we route through here. I2C cable we also route through here. And then this cable I also want in and up here. And once we've everything screwed down, there's a black rubber grommet that is going to go over all of these cables, so you won't be able to see them anymore. I won't do it now, just for visibility, just to make everything nice and clear. Good. So that gets held down, and then I'll take an M3x8 screw. This is going to be a bit fiddly. This has got to go into that hole in there. Okay, and it's only one screw. But due to the square nut and due to the fact that this guy is recessed, so this is basically how it's sitting in there. Okay, so that almost finalizes our assembly for the head and neck. Well, for the neck, really. So let's put that on the droid and see if we can have some fun with it. Cool. So here we got our droid. Powerless, of course, so not powered on. That's what I was trying to say. So we'll take our freshly assembled head and neck, put it in here. There we go. starting to look a bit like a droid. And now in order to add the head, we need the head plate. It gets put on to the top servo like this. Gets fixed in the front and the back with our already customary screws. Oh yeah, lest I forget, this guy, where's the camera? This guy actually also has a receptacle for a square nut in front. So let's add that real quick. And this is going to be used, this is one of the 3 mounting screws that's going to hold the head down eventually, and we'll fix it with a thumb screw because we're not going to be able to access anything from the top with a screwdriver. Good. This guy goes up here. All right. That's yeah. Full. Okay. Here. It's fine. All right. There you go. Here's our thumb screw that we're going to use to fix the head on. There you go. Okay. Good. So that works. And now what you want to do is to fix the head is you see that the head has this this flange here. So you go with the head mounting plate under this plate. Push it right to the back. Okay, and this head apparently has a bit of tolerance. The ones that I have on my printer actually will snap into that flange. It's not a big deal. And you take the thumb screw and go right in there into, see that hole there? That's the mounting hole. All right. That is our droid right there. Final thing is going to be the back plate with the aerials. All right, this step is entirely optional, which is why I'm going to go through it relatively quickly. I also didn't have a separate backplate or servos to build this live from scratch. As I said, it's entirely optional, but I know you crazy people are going to want to do it anyway. So let's run through it real quick. This is the backplate. It comes in 2 versions. One of them is with movable aerials. One is with fixed static aerials. These aerials are actually exactly the same for both versions. These consist of a printed TPU printed part on the bottom that I haven't painted. I think realistically it should be painted silver and black, but this one I just left as it is. It's TPU, which is a fantastic idea because people will want to wiggle on these things. It's good for them to have some wiggle room. Then these have a carbon rod glued into it, 15 centimeter. I don't think there's actually exact measurements published anywhere. 15 centimeter looked about right for me. And then there's a little aerial tip glued on the top. So this is basically all just glued together 3 times, same thing. And then they just get pushed into the receptacles. As I said, there's a backplate version where these are static, and that is actually recommended for a beginner build. You can still move to a movable aerial later. Now, if you're not doing the modification with the head counterweight, then I highly recommend going with static aerials, because it will save the 50 grams that the head is going to be too heavy unless you have a counterweight. So basically, if you do movable aerials, do the counterweight. Okay, so for the static backplate, you just glue on this backplate here, and then basically the whole thing just screws into the head, and I'll show you how to do that in a second. For the version with movable aerials, let me take one of these apart very quick, and I'll take these off so that we don't stress the servos. I'll just take one of these apart. So these come with a servo linkage. That's this gray plastic bit here. And then they come with this sort of assembly. It consists of a printable lever with a rod. You can use 2mm push pins. I'm using 1.8mm, I think it is, carbon rod. You can glue these in, but you don't have to. So this assembly basically goes into this hole here, and then it gets covered with this guy that also has matching recesses for the axis, and gets sandwiched by those. And the backplate here can either just use self-tapping screws, or you can tap them if you want. I do tap them because I use nylon screws looking like this. They can't self-tap really in the material, they break. And I use nylon screws because you basically can cut them down to size with a pair of pliers. But you can just as well just take, let me see. 4mm socket head screws. Good, so this dude goes in here. And take note of the assembly here. The way that I mount the servos is with the they have the gearbox here is with the gearbox towards the aerial. Doesn't really matter, but if you flip them, it will flip the direction that the aerials are moving. And this has a lever that's a bit off center, just a tiny bit, and so is the lever on here. So I'm mounting this in the opposite direction so that I can put the lever, the gray plastic part here, the linkage, in between. So put this in there. This one goes over it. And then the whole thing gets fixed with the nylon screws. All right, good. So for the servos themselves, these are, I mean, obviously super tiny. They are 1.5 gram airplane rudder servos, so they're very, very small and very delicate. And the way that you mount them is, you see these green bits here, that's TPU printed. That gets glued into the back plate, and then you screw with tiny screws that come with the servos directly into those TPU bits. Why TPU? Because these things are loud as hell. This back plate is printed in lightweight PLA. If you screw them directly into that lightweight PLA plate, then you're going to hear every single movement of the servos amplified. You don't want that. Good. In terms of electronics, that's probably best explained on the wiki. We supply this little plate here, this little PCB that goes, that has 3 receptacles for the 3 plugs, for the 3 connectors for the servos. And so this board here just screws onto the back plate here, if you will. There's a small little screw hole here. This really doesn't carry anything, so you can just put it any which way you like. Let me screw that on real quick. And the board takes 2 connections. I'll have a cable tie for this in a second. The board takes 2 connections. It takes the I2C that goes into this matching connector down there on the board, and it takes 5 volts. And the 5 volts that get supplied, I'm just using a pin header here. You could probably do that a bit smarter, but this is marked with minus and plus on the PCB. And the way this connects is I'm just routing the 5 volts out of the topmost dynamixel. So this is basically just a regular dynamixel cable, has the data pin cut off, and goes directly into this minus and plus, and you just have to make sure that you don't mess up the polarity. Good. It gives you this sort of assembly. And then let's mount that to the back of the droid's head real quick. All right, you'll notice that this is actually a different head. I just wanted to show you how the whole thing looks. We don't care about which head it is because the connections are all the same. So let's mount this on real quick. Now the way that you mount the back plate with the movable aerials is as follows. So you got your dynamixel cable, you got your power cable. The power cable goes into the remaining dynamixel. At the very top, there you go. The I2C cable goes into here. I always forget which way it should be. I think it's contacts down. Not entirely sure about that. Yeah, looks good. All right, and now if you look into the head, in this flange up here, there's 2 barely noticeable stoppers. And this, they take up this bit here. So that goes in there. And it's a bit of a tenuous hold until you fix it. Like many things with this drawer, this is a pretty fiddly thing until you fix it from the back with your 2 screws. Again, I'm using nylon screws here as usual. And I had a second nylon screw. Don't see it right now. Doesn't matter. So it's fixed. And right now it's only fixed with 1 screw and the tab at the top, but it's still, I call it fixed enough. And then the only thing to finalize is to take this linkage. As we said in the beginning, it's totally passive. So it takes this fat screw that is also 3D printed, that goes into here. No Phillips screws in Star Wars universe. This is probably the fattest regular slot screw that I've ever seen. And then the whole thing gets fixed at the bottom with this dude. All right, fine. So this is basically it. I mean, obviously we don't have tires on, we can't drive it yet. But in terms of mechanics, this is our finalized droid. And what we're going to do now is upload the final droid software and then see if it does what it's supposed to do. All right, let's see if it's doing what it's supposed to do. Switch it on.
Self-test starting.
Always running through the customary self-test.
Okay. Servos.
It's going to upright the servos.
Okay. IMU. Calibrating. Okay. Left motor. Okay. Right motor. Okay.
Cool. Good. So as you see, it's already reacting to the IMU with its servos. And let's add the aerials. So we can move the head with the remote. All right, and that's the last part of our tutorial. Thank you very much for watching, and I do hope you're going to start to build your own D-Ov2Evo soon. See you. Bye-bye.